Good morning. Today we're going to look at a couple triangle properties. One is called the triangle angle sum theorem. This might be a theorem that you're familiar with in the past. As we can tell, the triangle angle sum theorem here is stated for me. If I were to take this angle A, cut it out, and move it up here, take this angle C, cut it out, move it up here, notice what will happen with A, B, and C all together. They would create a straight line, thus supplementary, and there we have our triangle angle sum theorem. The three angles in a triangle will always equal 180 degrees. We'll practice with that a couple real quick. So here we have a triangle with a 64, 71, and an x. So I'm going to use the triangle angle sum theorem to say that x plus 64 plus 71 has to equal 180 degrees. Put your like terms together. X plus 135 would equal 180, and if I subtract the 135, I find that x is equal to 45. Another example might look like this with a x with more than one term and expression in for the x. It still works the same. I'm going to start with 3x plus 5 plus the 45 here, plus the 94, all has to equal 180 degrees. Start doing your like terms. I end up with 3x plus 144 equals 180. That's 5, 45, and 94 together. Subtract the 144, and 3x equals 36. And if you divide, you get x equals 12. Now, more than likely, this is not actually the answer to the problem. I might want to know how big this angle is. So of course I'm going to take that x and I'm going to plug it in to 3x plus 5, and I'm going to find out that it's 3 times 12 plus 5, which equals 41. I'd like for you to try now. There's two examples for you to try. Take just a moment, hit pause to try these two, and then I'll give you the solutions in just a moment. And here are your solutions. Another theorem we're going to look at today is called the exterior angle theorem, the exterior angle theorem. And what that's trying to get you to do is to realize that the two remote interior angles, those are the two angles way on the inside here, are actually equal to the exterior angle outside. So this says that the exterior angle, D, is equal to the sum of the two opposite interior angles, sometimes called remote interior angles. Let's take a look and see what that looks like. So we can see in this situation that they're asking me for an outside angle here, and you can tell that I have all three angles on the inside. Now, using the triangle exterior angle theorem, I know that x, my outside angle, is equal to the two remote inside, 65 plus 84. Well, that's pretty simple, pretty straightforward. I find out that x is equal to 149. Now, was that the only way to do this problem? No, but using the triangle exterior angle theorem, it was pretty quick and easy. A second way I could have done that is I may have noticed that these two are indeed supplementary. So if I chose, I could have said x plus 31 equals 180. And when you subtract x, you do get 149. So as you can see, you do get the same answer for both. Here's a more typical situation where you don't quite have all three angles. So it makes it very difficult to figure out this third angle. Now, there are still other ways of doing this problem, but to use the triangle exterior angle theorem, I recognize the exterior angle here, 140, is going to be equal to the two remote angles, the sum on the inside, which creates a pretty straightforward algebra equation. I can subtract 31 and find out that x equals 109. Alternatively, I could have found this supplementary angle here as being 40 degrees and then used the triangle angle sum theorem to find x. Take a moment on your own for a second, please, and try these other two examples. press pause, and I'll give you the solution in just a moment. And the solutions.